Hi, I'm Cassandra Brown, one of the many members of the DRFEWS Deglobalization Project at The Ohio State University. This is the first of a series of videos to share recent progress about DRFEWS. Now, if you're new to the project, you can visit our website for more information, including past videos. For now, we're providing a general overview of progress, but we'll be diving into specific details in future videos. So today, let's start with a quick project overview.
Our team's main goal is to consider how deglobalization might impact the sustainability of the Great Lakes region. To get there, we're combining several existing models to recreate the connections that exist between different systems. Our main focus is on food, energy, and water systems, but we're also considering connections to the manufacturing sector and impacts on households. By running our finished model under different scenarios, we can measure the impact that changes in global trade and environmental protection will have on regional sustainability. In this way, we hope to help decision makers choose robust policies that preserve general well-being under uncertain future conditions. Because this project touches so many different disciplines, our team includes researchers from all over campus. These individuals bring a variety of backgrounds in different modeling systems and policy areas. Their work is supported and enhanced by a talented group of graduate students responsible for important components of model development, coding, and background research. Our team meets regularly in small groups and as a whole team to maintain connections between the different parts of the project. But we also rely on ideas and feedback from those outside of our group. Our Regional Advisory Committee and smaller participatory modeling advisory teams have provided valuable insight throughout the project. If you're a member of one of these groups, thank you. We hope these videos will spark further input. Since our work began, we've come a long way in linking several models and disciplines together to run as one single supermodel. Not that kind of supermodel. Here's a simplified version of our current model of models. You can see the different submodels in blue. We're looking at the impacts our different scenarios will have on global and national markets, our regional economy over time, with an emphasis on specific economic sectors, farmer decisions, the ways land is used, how that affects natural resources, and ultimately sustainability. Much of our past and current work has involved calibrating these submodels to our specific region. We've also worked to ensure our submodels connect efficiently with one another, and that we have appropriate ways for our different scenarios to interact with the submodels. For example, one of the models we're using is the Soil and Water Assessment tool. The SWOT tool can calculate field-level results for crop yield, nutrient runoff, and other statistics useful to our sustainability assessment model. But first, our land use assessment team had to recalibrate the SWOT model from serving one watershed to serving a 5-state region. This involved finding, adding, and testing regional data on hydrology, topography, soil types, land use, and other data. Of course, regional data is not always available. To ensure our scenario effects on land use were realistic, our team conducted a survey of farmers and landowners in the region to measure their probable reactions to changing prices, along with several characteristics that might influence those decisions. And much of the data used to create our scenarios came from previous international studies, which we had to scale down to the regional level. To make these regional scenarios more probable, we relied heavily on input from our advisors, people with firsthand experience in food, energy, and water policy, who can help us determine plausible scenario changes that can intersect with our model. As we thought about how to actually apply these scenario effects to our submodels, we found that our original regional dynamic model, while good at providing economic data over time, was not providing fine enough detail for us to look at specific scenario impacts. Well, based on advisory team discussion, the economic modeling team was able to add a second economic model. And this one breaks down the sectors of interest so that we can model individual scenario impacts from changes in commodity prices, land use, and competition for natural resources. As we work towards a final DRFEWS system, we're ensuring that our submodels will provide the data points we need for our final sustainability assessment. But more importantly, we need to ensure that our definition of sustainability will resonate with policymakers and citizens, whom we hope will ultimately benefit from our project results. Involvement from our advisory committee will again be critical to help craft a definition of sustainability that takes in many considerations. This summer will be a key time for our team to collaborate and combine work and our individual objectives into one cohesive project. Our goal is to run our first data sets this fall and be ready to present them to our RAC members for commentary. To that end, we look forward to considering individual input from our industry advisors and colleagues as we move towards usable outputs.
Throughout the summer and early fall, we'll be sharing additional videos to discuss specific challenges in our project objectives and provide more detail on our various submodels. We have many areas where feedback and input are much needed, so we hope to hear from you with questions, comments, ideas, or concerns. You can visit our website to find contact information for our individual team leaders. And as always, we welcome and appreciate your input.